Alright, so now let's take this a little deeper here. Example 3 says, the spinner in example 1 is spun twice. Okay, is the probability of spinning A more likely with 1 spin or with 2 spins? They want a prediction. Well, let's think about this. The first time we spin, okay, there's 1 chance of getting A. If we spin it again, there's another chance of getting A. So that's 2 possible chances that we've got all of a sudden. Okay, so the probability should be more likely with 2 spins. With 2 spins. Okay, so this right here is just a little abbreviation for with, a W with a slash after it. Okay, so it's more likely with 2 spins to get an A, because the more times we spin, the more likely the chance is of getting an A at least one time. Okay, so B says find the probability of getting A at least once. Now for these kind of problems, you'll notice here I got a table. Okay, it will benefit you greatly to make a table. So up here I've got my first spin, and I got 4 things that can happen on my first spin. And over on the side I got my second spin, and the same 4 things can happen. Well, if I put those spins together, I can get an A on the first spin, an A on a second spin. So that's an A, and then an A. I could get an A on the first spin and a B on the second spin. So that's an A and then a B. And I could get an A and then a C, or an A and then a D. Then in this column I could get a B first and an A second, or a B and then a B, or a B and then a C, or a B and then a D. And if my first spin I get a C first, I can get a C and then an A, or a C and then a B, or then a C and then a C, or a C and then a D. And if I get a D first, I can get D and then A, or D and then B, or D and then C, or D and then D. This in here is all the total things that can possibly happen when I spin the spinner twice. So this is my sample space right here. If they asked me for the sample space of this, I would have to list all of this. All the ways I can get A first, all the ways I can get B first, and then C first, and then D first. There's 16 possible things that can happen here. So this is also the total number of outcomes I have. Okay, that is key. That's the total number of outcomes is 16. So now look at part B. It says find the probability of getting A at least once. So I need to look at my table and tell how many times in here do I have A at least once. Well, I've got 1, 2, 3, 4, 5, 6, 7 ways to get A at least once out of this spinning the spinner twice. Out of how many total things can happen? Means it's probability. Well, we just said there were 16 things total here. So I've got a 7 out of 16 chance of spinning A at least once. So that's almost half, but not quite. Okay? In part C, it says find the probability of not getting A at least once. So I got to look in here and tell how many ways can I not have A at least once. Well, all of these have A at least once, so I'm not going to count those. But I can look at 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 ways to not get A once out of 16 possible things total. And that 9 out of 16 does not simplify either. So that's my probability. Again, this is the number of favorable outcomes of not getting A. There's 9 different ways that could happen over the total number of things. Okay? If you've got 2 events like this, okay, it's a great idea to make a table. Okay, that's pretty easy to do for 2 events. So say I flipped a coin twice. We could do a table like this to show all the possible outcomes. Okay, or say I rolled a die twice. A table like this would be pretty easy to make. Once we get more than that, though, it starts to get a little more complicated and tables aren't as good. So let's go ahead and look at another example. Alright, now on to example 4. It says Nathan flips a coin 3 times. Then we want to predict which is more likely, that he will get heads at least once, or that he will not get heads at least once. We want to find the probability of getting heads at least once, and we want to find the probability of not getting heads at least once. Okay, so for the last example, when there were only 2 events, we made a table. However, that doesn't work very well. It's not very easy to organize when we have 3 or more events. So when we have 3 or more events, we want to make a tree. Okay, I'll show you what a tree looks like here. We're going to have our first event. Okay, in the first event we're flipping a coin. Alright, well when we flip a coin we got two possible things that can happen. We can get heads or we can get tails. Okay, then we got to represent our second event. In our second event we're going to make a tree off of the first event. And again we can either get heads or tails. So I can get heads first and then heads again, or I can get heads first and then tails again. In the same way, I can get tails first and then get heads, or tails and then tails. Then for my third flip, well, I can get heads and then heads again, or heads then tails. And again, on the third flip, I could get heads first and then tails. Then on the third flip, either heads or tails. And the same thing with these two. I can get heads or tails for the third flip anytime. Alright, so my sample space for this problem, what all can happen? Well, I can start with heads. And when I start with heads, I can get heads again. And then after that heads, I can get heads again. That's one thing that can happen. I can get 3 heads in a row. Or I can get heads, and then tails. Okay, and that would be this way. Heads, then tails. Well, I can get heads on my first roll, and tails on my second roll, and then heads again. Or I can get heads, and then tails, and then tails. And that's all the possible ways I can start with heads. That's all, whoops, all of those in there. Okay, sorry, you don't need to circle that. That was an accident. I meant to use my laser here. All of these. Okay, in the same way, I can start with tails and then get heads and then heads. I can start with tails and then get heads and then tails. So tails, then heads, then tails. I can start with tails and get tails and then heads. So tails, tails, heads. Or I can get tails, tails, tails. Okay? We will predict which is more likely, that he'll get heads at least once or that he will not get heads at least once. Well, look at all of these sample spaces. I get heads at least once here, and here, and here, and here, because at least once means one or more times. So the only time that I don't get heads at least once is this one. So for part A, it is more likely that we get heads at least once. Okay? Then part B wants to know the probability of getting heads at least once. Well, that means, again, probability means we want to know the probability of getting heads at least once over the total outcomes. Remember, probability is total outcomes. Well, we did my sample space. Look at all the ways I can get heads at least once. There's 1, 2, 3, 4, 5, 6, 7. Okay? So there's 7 ways to get heads at least once, and there's 8 possible ways that this thing can turn out. Okay, so there's 8 possible things in my sample space. And when you make a tree diagram, the nice thing is your total number of things that can happen is always how many you have in this last little column over here. Well, look, there's 1, 2, 3, 4, 5, 6, 7, 8. That means there's going to be 8 total things that can happen. And then for part C, the probability of not getting heads at least once. So this is not heads once over my total again. When I look on here, there's only one way to not get heads at least once. So that's 1 out of 8 total things again. So there's my probability. Alright, and let's move on to another example. Alright, and the last example. Emily is a softball player who has 21 hits in 60 at-bats. It says to express the probability that Emily will get a hit in her next at-bat as a decimal with 3 decimal places. Emily's coach needs to decide whether to have Emily bat or to use a substitute hitter whose batting average is 300. And it says batting averages are usually expressed without a 0 in the ones place. How would you advise the coach? Well, the first thing is we need to know the probability that Emily's going to get a hit. So the probability that she gets a hit over her total at-bats. Well, she has 21 hits in 60 at-bats. And if we were going to reduce that down, the 3 goes into 21 and into 60, so 21 divided by 3 and 60 divided by 3 gives us 7/20. So she's got a 7 out of 20 chance to get a hit. Now it says to express this as a decimal with 3 decimal places, and the reason is because in baseball or softball, batting average is always written like this with 3 decimal places. So we want to express this with 3 decimal places. So we're going to do the top divided by the bottom to get a decimal. Okay, and that's 0 point. We'll put a 0 in here. 20 goes into 70 3 times. Multiply and get 60. Bring down a 0. 20 goes into 100 5 times, and that's 100. We got nothing left over. Okay? So we got 0.35 for our answer, but it says we want to express this as a decimal with 3 decimal places, and a batting average is always put without the 0 in front. Okay? So I just want the 3 decimal places. Well, I've already got 0.35. Then I need to throw a 0 on the end. And that's Emily's average. So Emily is batting .350. That's a good batting average if you know anything about baseball or softball. Then the substitute hitter is hitting .300. So who do you think you would rather have hit? Somebody with a .350 batting average or somebody with a .300 batting average? We're going to look for the higher number, and the higher number is .350. So we're going to say, we'll advise the coach that Emily should hit instead of the sub. So Emily should hit instead of the sub, because she has a better batting average, and so that means there's a better chance that she's going to get a hit. So she's a little better hitter. Alright, if you guys have any questions, ask. Otherwise, good luck on your homework.